Okay, in today's lecture, we'll start with Dijkstras single source shortest path algorithm. Okay, so first we'll see what is single source shortest path problem. So given a graph G with V number of V vertices and E edges and a source vertex X in V, find the minimum cost path from S to every vertex in a V. Okay. This is single source shortest path problem. It means in a given graph, we have to find out distance, shortest minimum distance from one source. That is, suppose in the given graph, we consider source as a source vertex as a vertex A. Here we have to find out minimum cost from source vertex A to all remaining vertices. That is, we have to find out minimum distance from vertex A to B, vertex A to vertex C, then vertex A to vertex D, and vertex A to vertex E. Okay, this is the problem of this is single source shortest path problem. Okay, so we'll start with Dijkstras shortest path algorithm. So this Dijkstras is well known and a popular algorithm for solving shortest path problems. Here graph is given and a source vertex in the graph is given. We have to find out shortest path from source to all vertices in a given graph. Okay. So here we generate a shortest path tree with a given source as a root. Okay, then we maintain two sets. One set contain vertices included in a shortest path tree, and other sets includes vertices not yet included in a shortest path tree. Okay, at every step of algorithm we find a vertex which is not yet included and has a minimum distance from the source one. Okay, so this is all about Dijkstras shortest path algorithm. Okay, so here are the steps. Here first step is, here we have to initialize the cost of each node to infinity. Okay, then we have to initialize the cost of source to 0. Okay, now in the next step, while there are unknown nodes left in the graph, okay, as we already discussed, here we maintain two sets. One set here one set contain vertices included in a shortest path tree, and other set includes vertices not yet included. Okay, it means here we have to select the unknown nodes, okay, with n lowest cost. Okay, here we use greedy choice. Why? Because Dijkstra's shortest path, it means this is minimization problem. Okay, it means that is nothing but optimization. Okay, so optimization problem can solve by using greedy approach. Okay, then next step we have to mark n as a known. That is, we have to include that in a first set of vertices. Okay, then third step is, for each node A adjacent to n, okay, if n's cost plus cost of n comma A is less than A's cost, okay, then we have to change A's cost. Okay, it means, now we'll see one simple example. Suppose in this graph, okay, distance A to B is given. Okay, distance A to C is given. Okay, but distance A to E is not given. Okay, so in that case, if direct distance is not given, okay, then so if direct distance is not given, we consider that as an infinity. If we find out minimum distance, if we consider this path A to B, that is 2, B to C, that is 1, and C to E, that is 2. So here we can modify this path. Here we can say we can modify its value, and that is nothing but relaxation. Okay, so this is the simple algorithm. Okay, here overall way to solve this algorithm is, first we have to set all distances to infinity. Okay, then we have to select source vertex, and we have to initialize its distance to 0. Okay, then from this source vertex we have to find out distance from this source to remaining all vertices, and as here we use greedy approach, so we have to select minimum distance. Okay, then the selected distance, then we have to mark that vertices as a visited vertices. Okay, then we have to find out the remaining distances. Okay, now we explain this algorithm by using the simple example. Okay, here this is the graph with 5 vertices, that is vertex S, U, V, X and Y. Okay, so here first step is initially we have to initialize all distances to infinity, and from S is the source vertex, so we initialize source to 0, that is our second step. Okay, so it means we select this source vertex, okay, S. Now we have to find out distances from S to remaining vertices. If direct distance is given, we consider that value. If direct distance or direct path is not there, in that case we consider that distance as a infinity. Okay, now in this uh, graph, S to U distance is given, that is 10. Okay, S to X in distance is given, that is 5. Okay, there is not a direct path from S to V, so we consider this distance as infinity, and again S to Y, this distance as infinity. Okay, it means now there are 4 paths with distance 10, 5, infinity and infinity. Okay, so here we have to select minimum distance. Okay, then from this 4, minimum distance is 5. Okay, it means we include vertex X in a visited vertex. Okay, so first initially visited is S. Okay, then next visited is 5. Okay, now from this 5, there are direct edges from 5 to 8, 5 to 14 and 5 to 7. Okay, initially here we selected only source vertex, that is S, so there is no direct path from uh, source vertex S to V, so we consider that distance as infinity. S to Y, that distance again as infinity. Now we next vertex selected is 5, so there is path from 5 to 8, and if we consider from source 0 to 5, then 5 plus 3, that is from source to vertex U, okay, via vertex X, the total distance is 8. Okay, then this 5 plus 9, this distance is 14. Okay, then 5 plus 2, this distance is 7. Okay, it means from this 3 we can select any one, okay, with minimum cost. So minimum cost is 7. It means here we select vertex Y. Okay, now okay, in previous, okay, here this distance is 8, this distance is 14 and this one is 7, so we selected this 7. Okay, now there are 2 vertex, one with distance 8 and another with distance 13, so we select minimum one, that is 8. Okay, so from so there is a distance from S to V is 13. Okay, but if we select this path from U to V, this distance is 9. Okay, this distance is 9. Okay, so we finally select this vertex V. Okay, so final, here we get distance from source vertex to each vertex. Okay, it means from source S to vertex U, distance is 10. From this vertex S to destination vertex X, this distance is 5. From this S to V, this distance is 9. And from this S to Y, this distance is 7. Okay, and all these distances are the minimum cost. Okay, we'll see one more example. Okay, here 6 nodes are given. Okay, 1 2 3 4 5 6. We consider first node as first vertex as a source vertex. Okay, and here we have to find out, okay, and here we have to find out distance from source to all other vertices. Okay, so initially we consider this selected node as a 1, So 1 to 1, this distance is 0. Okay. Then 1 to 2, there is direct path with the distance 2. 1 to 3 with distance 4. 1 to 4, there is no direct path. So we consider that as an infinity. For infinity, I mention here in. For 1 to 5, there is no direct path. So we consider in infinity. And 1 to 6, there is not a direct path. So we consider infinity. Okay. So here there are two paths, 1 to 2 with distance 2, 1 to 3 with distance 4. So minimum is 2. Okay, it means we select vertex 2. Okay, so include this 2 in a selected node. Okay, then now from 2 to 4, okay, there is one path 7. Okay, so from the source vertex, okay, this distance is 2 plus 7. Okay, so this distance is 9. Okay, so we mark this visited vertices with different color. Okay, this distance is 9. Okay, this is as it is 0 to now, sorry, to 4. This is 9. Okay, then there is one path 2 to 3 with distance 1. Okay, as 1 to 3, 1 to 3, there is direct path with cost 4. Okay, but there is a one more path from 1 to 2, 2 to 3 with cost 3. As 3 is less than 4, so we consider here minimum cost 3. Okay, then 2 to 5, there is not a direct path, so we consider that infinity, and this value also infinity. Okay, so okay, now we have to consider this 2 is already selected. Okay, we have to select vertex from not yet included set. Okay, so from this 3 and 2, 9, this 3 is minimum. Okay, so we select this node 3. Okay, now from 3 to 5, there is one distance with cost 3. Okay, it means if you consider this path, okay, 1 to 2 plus 1 plus 3 with cost 6. Okay, so it means this cost is 6. Okay, okay, this cost is 0, this cost is 2. Okay, this 3 already visited. Okay, then with 4, okay, 1 to 4. Okay, this distance is 9 as it is 6. There is no direct path, so we consider that as infinity. Okay, so from this 9, 6 and infinity, we have to select minimum one. Minimum is 5. Okay, so we consider 1, 2, 3, then we consider vertex v in a 5. Okay, with cost 6. Okay, so this 5 is selected, so there is direct path from 5 to 4. Okay, so distance up to from source vertex 1 to 5, minimum distance is 6. Okay, then from, if we consider this path, okay, 5 to 4, that is this distance, if we include, okay, it means now this distance becomes 8 and previous is 9. As 8 is less than 9, so we consider 8 here. Okay, this 6 is already visited. Okay, this 0, 2, 3, all these are the already visited, and 5 to 6, this distance is 5. Okay, it means 6 plus 5, that is 11. From 6 and 11, okay, we have to consider minimum one. Minimum is 6. So sorry, from this 8 and 11, because 6 is already distance 6 with node 5. Node 5 is already selected. We have to select minimum distance from not included node. So there are only two remaining nodes, 4 and 6. that is not included yet. So from 8 and 11 we have to select minimum distance, and minimum distance is 8. Okay, so we include here, we include node 4, okay, with this distance 8. Okay, 0, yeah, this 2, this 3, this 8, okay, this 6 is already there. Okay, and if we include this path from 4 to 1 with cost 1, okay, it means 1 to 4, cost is 8 plus this 1, that is total cost here is 9. Okay, it means now we have to select node 6, 1 comma 2 comma 3 comma 5, then 4 comma 6, okay, with distance 9. Okay, it means if we consider this column, okay, from source vertex to vertex 1, minimum distance is 2. From source vertex 1 to vertex 2, minimum distance is 2. From source vertex 1 to vertex 3, minimum distance is 3. From source vertex 1 to vertex 4, minimum distance is 8. From source vertex 1 to vertex 5, minimum distance is 6. And from source vertex 1 to last vertex 6, its minimum distance is 9. Okay, this is here to analyze time complexity of this Dijkstras shortest path algorithm, that is depend on how we implement priority queue. As we have seen in the previous lecture, that we can implement priority queue by using binomial heap as well as by using Fibonacci heap.